In this video, we'll talk about averages. I'm sure the average value of functions and see how that works towards looking at areas under curves. So what's the average value of a set of numbers? Well, if I have n numbers, a sub 1 up through a sub n, then their average is just a1 plus a2 plus a3 plus all the way up to an, and then divide by n, right? I take the numbers, add them all up, and I divide by the number of numbers that I put in there, and that will give me the average of those numbers. Now, I want to try to visualize this in a picture form so I can see where we're going with looking at the average value of functions, because for functions, we don't really have a finite number of numbers we can deal things with. So as a picture, how can I visualize this average value? What I can think about is a bar graph for each of these numbers above. Something like this. So we've got a1 here, a2, and then we'll say each of these is with 1 just for the sake of labeling things. So 1, 2, 3, and so on. Now from this, how can we get the average value? Well, if this is at height a1 here, then the area of this rectangle here is a1, a2, and so on the rest of the way. All of these rectangles have area corresponding to their height, which is the value above. Then the area under this bar graph corresponds to the sum on top of that average part. So area of bar graph is a1 plus a2 plus a3 all the way up to a8. And then to get the average value, you can just divide this by the number of bars, or also by the length from left to right here. And that's the idea we're going to run with here. I could find the average value by finding the area inside this bar graph and then dividing it by the length over which this bar graph extends. Now, what about for functions? We don't have a list of n numbers we can play with here because we have functions defined for a whole bunch of values, infinitely many values, in fact. And I want to find its average value. Well, if the function's constant, that's easy, right? For a constant function, the average value should just be the value of the function. And this fits our model of taking the area under this graph and dividing it by the length of this interval. If this interval has length 5, the area here will be f of x, whatever the function value is, times 5. And if I divide then by the length of the interval, I'll get rid of the 5 and be down to just the function value. So if the function is not constant, how could I find the average value then? Well, I could do it in the same way. I could take the area of this shape here and divide it by the length of the interval that this is supported on. So for this function f here, the average should be the purple area here divided by the length of the interval, which is b minus a. And that's how we directly find the average value of functions. We find the area under the curve and divide it by the length of the interval which we're supporting it. Now all we can do at this point is approximate this, but we can approximate the area using rectangles like before, and then still divide by the length to get an approximation to the average value. Let's see an example of what that might look like. To estimate the average value of the function y equals 4 minus x squared on the interval from minus 2 to 2 using a midpoint sum with 4 rectangles. Let's draw a picture. Something like that. And we've got minus 2, minus 1, 0, 1, and 2. Assume that's evenly spaced. And we're going to use these for our rectangles. Now to estimate the average value, I am going to find the area using rectangles and then divide it by 4 because it's like this interval. We want midpoints, so I want my rectangles to be, that should be symmetrical, it's definitely not, but that gives us an idea what we're trying to figure out here. So the area that I'm looking for is going to be the function value at minus 1.5 times 1, because the interval has width 1, function value at minus 0.5 times 1, function value at 0.5 times 1, function value at 1.5 times 1. I can plug all these values into f. I get those numbers. When I add them up, I get 11. So our approximation of the area here is 11, which means our approximate average value is 11 over 4. That's the idea of the average value of a function, how we can approximate using our rectangle approximation to areas that we talked about previously.